name is Linda Grand, and I work for the City of Palo Alto Utilities and help run our water conservation program. We're excited to hold this webinar in partnership with Bosca. I'm going to go over a couple of background information, and then we'll get to the presentation. One second. Okay. As you can see, all attendees are muted by default. We are going to save most of our questions for the end of the presentation, but throughout you can put your questions in the Q&A. And at the end, we'll also let you be able to raise your hand so you can ask Shelky directly. This webinar is being recorded and will be made available on the Bosca website. We'll also send a follow-up email to everyone who has registered with the recording link. So Bosca represents 26 agencies that include cities, water districts, a water company, and a university, all that purchase water from San Francisco. Bosca member agencies provide water to 1.8 million people and over 40,000 businesses. Outdoor water use represents the single largest untapped opportunity for water conservation in the Bay Area. And we're really here to promote it through water efficient plans, innovative techniques such as drip irrigation that you're going to hear about today. So if you live in Palo Alto, we partner with Valley Water on several rebate programs. If you want to take out your grass and put in drought tolerant plants, we have rebates of up to $4 per square foot of lawn replaced. We also have $400 rebate per installed laundry gray water system. We have stormwater rebates for cisterns and rain barrels, and we partner with Valley Water on their drip irrigation rebate as well. In addition, if you want to learn more about your water use, I suggest that you log on to WaterSmart. This is connected to the city's MyCPAU billing account. It's a great portal for you to see your monthly water use. We recently connected to hourly usage data. So if you've received a new AMI meter, you'll be able to log in and see your hourly use, see those irrigation trends, and learn how much water you're actually using for your irrigation, etc. And we also offer free mulch from Hopkins Tennis Courts and Mitchell Park. And there's a compost giveaway station as well. So for more information, go to cityofpaloalto.org/ways-to-save. We want to give a shout out for our heat pump water heater program. You know, there's always a connection to energy and water. So we're promoting for people to get off gas and install a heat pump water heater. We have a great program where the city will take care of everything, permits, etc., and you get this new heat pump water heater. If you don't live in Palo Alto and just a general Bosca member agency, I suggest going to the Bosca website to find what your city offers. But here's kind of some of the overview. So Bosca, similarly to the landscape rebate, has a lawn be gone rebate. In addition, there's up to $200 rebates for rain barrels. Bosca also has a smart controller rebate and installation program and a rain garden rebate. Bosca has several upcoming workshops, and I highlighted the Palo Alto ones. Join us on October 19th for a really fun pollinator plants walk and talk. So we'll get a short presentation at Rinconada Library and then walk over and see some of the local pollinator gardens, see some of the plants that you can think about putting in your own garden. And then we have a rain garden workshop coming up as well in November. So please go online and register for these classes. More resources at bayareagardening.org. And with that, I'm going to introduce our instructor. So Shelky Tao is a landscape designer and a founder of waterefficientgardens.com, an online landscape design business that excels in low water and native plant garden design. She received her Certificate of Achievement in Environmental Horticulture and Design from Foothill College, and is very experienced in the irrigation space and in the landscape space for low water use plants in native gardens. If you go through our Valley Water rebate program, there's actually an opportunity to meet with a designer such as Shelky and get that initial consultation for free as long as you go through with the rebate. So we're really excited to have Shelky on board.
Thank you, Linda. Hi, everyone. Welcome to tonight's talk, drip irrigation. Let me share my PowerPoint. Okay, so tonight we are going to talk about drip irrigation, a very interesting topic, definitely a big part of water efficient garden, low water use garden. So if we look at a low water garden, like the one we are looking at right now, there are several key components. Low water use plants or native plants, that's component number one. Component number two is the mulch, as you can see here. And number three, I would say it is the drip irrigation. So all these factors combined together make a garden water efficient. So yeah, as Linda introduced, I'm Michelle Key and I'm the founder of Water Efficient Gardens. So what is drip irrigation? It is a method of watering plants that slowly dripping water onto the soil at the root zone of the plant. So it is considered the most efficient way to deliver water to plants. So these are some of the examples of drip emitters. So here you can see both of these drip emitters. The flow rate is from 0.5 to 6 gallons per hour or GPH. Each emitter, typically the output is about 0.25 quarter per emitter. Another type of drip is we call bubbler or micro bubbler. So as you can see, the water is kind of like bubbling out from this emitter. So this one, the one big advantage about this kind of emitter is that you can adjust it. So you can adjust the water volume to make it from 0 to all the way up to very high. So this can come in very handy for the native plants because a lot of native plants, they don't need water or they really don't like water during summertime. So when we have this kind of bubblers, then during summertime, then we can just shut the water off. So those native plants can don't need to have experienced the overwatering problem. Another type is micro spray. So here it's basically the same, but it's just the water is like the water volume can be higher. Another one, we call it drip line or soaker line. So these you can't really see it here, but they have holes like every 6 inches or every foot or every 18 inches. So the water will just go out from those holes and just water the area along the pipe. So drip lines are especially important for trees because that's a very good way to water the trees. As you can see, that's how here the several rings of the drip line this way can fully cover the whole root zone for this tree. So depending on the size of the plants, we can use different size, the emitters of different sizes. For small plants, perennials, usually one emitter is enough. One normal 1 gallon emitter is enough. But for bigger size shrubs or trees, then we need more emitters. For trees, as mentioned, drip line would be good because it can distribute water evenly across its whole root zone. So what are the differences between drip and sprinkler? The difference is huge, right? As you can see, for this kind of drip system, the output at most is just 6 gallon per hour. Here, this kind of sprinkler, it's like 4 to 11 gallon per minute. So if you times 60 minutes, so you get something like 240 to 660 gallons per hour. That's like 100 times more than the drip. So that's why you can see this drip system can save so much water because the output simply is just so different. And because of the difference of the water volume, then following that, then there are two direct results. One is that for drip, it's not easy to have runoff because all the water just go down into the root zone. So you won't see a runoff like this unless you really put this drip for a long time. Another way is that because the water just go into the soil, it won't be spray into the air like this. So the evaporation is much, much lower. So because of these two big differences, so that's why the drip can, the efficiency can be so much higher than sprinklers. A little bit history of drip. So it is founded, it was invented in Israel by Simcha Blas. So how he invented this was he noticed a tree was doing very well without any watering. And actually it was eventually it's in effect that receiving drip irrigation. So from that, he got the inspiration and he invented the drip irrigation, and he later patented it, and then started this created Netafim irrigation company. Netafim today, this product, this drip line product is the product's name is literally Netafim because they created it and they make it the product it is today. Today, Netafim is like they have over 30% share of the global drip irrigation market, and it's a billion dollar company. So drip not only can use for gardens, they can really use for agriculture. As you can see, drip is not only to deliver water, but it can also be very efficient in delivering nutrients to the crop. So it's also a very good way to water crop for agriculture. So let's take a look at the main components of a drip irrigation system. So as you can see, these are the main components: a backflow preventer, connectors and fittings, main tubing, pressure regulator, filter, emitters, and end caps. So I will just call out these two. The others are relatively straightforward. So backflow preventer is something like this. You connect to the valve, the main line, so that as its name indicated, it prevents the backflow. Why do we need that? Because we don't say this is the main water source. So it's potable water. So it usually going this way. But then say this pipe here, it's connected to the irrigation, the drip irrigation. So if the water flows back, we don't want it to mix with this potable water. So that's why we have this mechanism here. If water flows this way, it can go flow fine. But if water flows this way, then this piece will pop up and block the water from going in and mix with the potable water. So that's why we, for any irrigation tubing, we need a backflow preventer like this to make sure the water stays clean all the time, the potable source. Another important piece is the pressure regulator, like this one, as you can see. So for drip, it can only use 15 to 30 psi. So, and the city main usually is the pressure is higher than that. So before this water can be used for drip, then we need to have this regulator to lower the water pressure, so the drip system can work fine. So how do we install a drip irrigation? So the first step is that you have a plan, right? Say you have all these plants that need to be watered, and you have this vegetable bed. So then you first have the plan like this. So from this valve, then you connect one pipe, one tube, and then it can cover all these plants. Another valve, then it can cover all these vegetables in the vegetable bed. Same for the other plants. So you just think about how where all the plants are and how to lay out how to run the pipes so that it can they can cover all the plants that need to be watered. And after you have the plan, then you go ahead and just connect all the pipes. So as we talk about, say this is the main line, and suppose the backflow preventer is something already connected here. Let's assume, or something like here. So this pipe, this tube is safe for irrigation. Then you can see here that that's where we put in the pressure regulator, and then we put in the filter. The filter is important so that the debris or all kinds of dirt will not block the flow of the water. And here, these two can be the pipes for the drip irrigation. So then after that, then you just lay out the hose and go around all the plants that need to be watered for that area. And after you lay that out, then you just punch holes and then next to the plants so that the water can just go to the plant like this. Irrigation, especially the time to irrigate depends a lot on the soil type. The best state for watering is that you do deep watering, but not runoff. So you usually after the new plants go in, they need about 1 year, 1 to 2 years to establish. But once they are established, especially for native plants, they need very infrequent watering. They can do very well, mostly just by natural water. But they do need watering still, especially in hot summer days. And the correct way is to deep watering. Deep watering means the water soaks deep down, all the way down to about 6 to 8 inches, as you can see here. But then we should not also avoid overwatering because that will create runoff. Even for drip irrigation, we can have runoff. So the key is to strike that balance to make sure the water can go down to this deep, but then not overwater. To do that, then we need to find out what soil type we have. There are 3 main types, sand, loam, and clay. You can find out by do a very simple test. You can get the soil and then add some water to it, and then try to make a ribbon. And if you can make a ribbon like between 2 to 4 inches long, that means it's clay, or just longer than your palm, basically. If you can make a ribbon longer than your palm, then that's pretty much a clay. If you can barely make any ribbon, that's sand, and anything in between that's low. Here in the Bay Area, a lot of area we have the clay soil type. So for every soil type, they have their so-called field capacity. That capacity, field capacity means that if you keep, that's the capacity it can absorb water. If water is over that capacity, then it will just run off. So the key here is not to overwater, not to be over that field capacity. So for example, that capacity, it reaches that capacity at 30 minutes, then we should not water more than 30 minutes once. So as you can see here, even for drip, it's possible to overwater. And anything that comes, if you can see this image here, especially for soil, for clay soil, it tend to go pretty shallow like this. And if you water it, overwater it, and that water will just go to the surface, and that can be lost to evaporation. So the key is not to water too long for once. So how do we do that? The key is to break that into 2 times in the same day. So for example, for a specific plant, it needs 80 minutes watering each week. And we want to do just water twice a week. So each time we need to water 40 minutes. But as we just mentioned, that at 30 minutes, it will already run off. So then we break that into two times. Each time we just water 20 minutes. So when we program the controller, we can program it, for example, the first time at 5 a.m., for example, and second time at 7 a.m. So that way, then, yeah, it can be 20 minutes each. The plant can have all the water, but then it will not run off. So for native plants, they are usually low water plants. And as I just mentioned, they need flexibility. So the micro bubbler is a very good emitter for native plants. Some native plants like Ceanothus, they just don't like any summer water. So then for those plants, then just remember to turn the water off during summertime. For trees, then we should use a drip line like this, and we should do deep watering. The rule of thumb is that it's for each inch of the tree's diameter, we need to do 10 gallons of water. So for a typical tree, it might be a little bit on the too much end, a little bit too much, 10 gallons. Let's say 5 to 10 gallons. So, but even with that, for a typical tree, we should try to give it like 90 to 180 gallons water each time, so that we can do the deep watering. For the trees, they don't need to water every week, but we can do it like once every 2 months or once 3 months. But when we do it, we should really go deep. So if you have this kind of like drip line, it can, for example, it can be like that when we are doing it, it can be like 1 hour long or something, for something like that for a long time to make sure the the watering is deep enough. Another key is that we should, because of this its own schedule, its own demand for the deep watering, we should put it on a separate station so that we can do it once every 2 months and for 1 hour, for example, instead of just like any other, those other plants where we do it like once every week. That's why to have stations, different watering zones are very critical for a low water garden. This way we can separate and treat different plants separately so that we can meet each of their water needs well without wasting water. So yeah, we can also use drip for vegetable gardens. Again, as mentioned, different plants, they just have different water needs. And we just need to have different programs to meet those needs. The way to do that is to set up hydro zones. You group plants with similar water needs in one hydro zone, and then you put them in one program that in the controller for one program. If you look at this backyard, so there were actually three zones. Zone 1 is this long. That's the water need is the highest. Zone 2 is this native garden and rain garden. The water need is low. Zone 3, actually, I would say is this redwood tree. So all these three have very distinctive water needs. So we should just put them, program them on 3 different stations. If you look at this front yard garden, you can also see there are 2 different water zones. Water zone 1 is this vegetable bed, and zone 2 is this low water garden here. I want to give an example of how we use the drip irrigation, how we plan it, and build this Northwest YMCA community garden. So the YMCA is in Cupertino. Here is the lawn at the back of the YMCA building. It used to be this big lawn and then have these sprinklers. Then YMCA decided to turn that into a community garden. So this is the design I did. It's a combination of community garden with 12 veggie beds and all native plants. And from the design, this is how I planned the layout of the drip, the pipes. So these are all the valve, where the valves are. So we have 2 lines to cover all the plants, and then 1 dedicated line. I think that's E, station E, that just cover the 3. Here it shows 2 trees, actually 3 trees. So we go through all 3 trees so that, and we have dedicated watering for these trees. So it's a volunteer project. Everyone came on a Saturday and just planted all the plants. That's after the planting. At that time, the drip was not done yet. So these are actually, actually this one, the drip was just installed. And so as you can see, that's the first watering, how it shows. And then just 9 months later, with all this drip irrigation, that's how the plants turn out. So as you can see, native plants plus drip irrigation plus mulch, that's a great combination that can give you such a beautiful native garden. So all these plants here, they are watered by drip irrigation. We actually turn off the watering from November. We planted it late September, and then we turn off all the watering from early November all the way to next May, because we received a lot of rain that year. That was 2 years ago. And there is no problem whatsoever, and the plants all did so well. And as you can see, with like full 6 months, water totally off. And so the water saving, we did not have the number, but it will just be huge compared to when it was long, as you can see. I want to also introduce to you Irrigation Scheduler. It's a really good tool. It's a tool on the Valley Water website. So you can, I think it's just called Valley Water Scheduler, something like that, scheduler.com or something like that. So here you just, they just ask you to enter an address. Here I just enter the YMCA's community gardens address and the controller you use. So you enter this some simple information. Then it asks you to describe what type of plant material you have. So the first one is low water. Here, low water use, and 5 different types of water use plants, sun exposure, irrigation type. So here I selected a drip emitter. It's full sun, and there it is. You can see the see schedule button here. So I click on that, and then it gives you the schedule for every month of the year. So as you can see, for October, I should do 3 cycles every day, and then each time I should water 7 minutes, and then just do it once per week. So for the YMCA specific, the location, the soil type, then this is the watering schedule recommended to me by the scheduler. So you can use it for your home garden and just get a recommended timer, the length of time and number of times. So as you can see, that's what I just explained, why you should do it 3 cycles per day instead of doing it like 21 minutes in one go. This way, we can make sure there is no water runoff, and all the water can be absorbed well into the soil. So after you get the time, then you can just program it in your on the controller. So if it's the traditional model, you can just go to the runtime here and just put in like 7 minutes each time, and then 3 times on each day on the watering day. And then if it's a smart controller, then same thing here. You just go to schedule 1 times and then put in the 7 minutes and 3 times. Here's my contact information. So if you have any questions about drip irrigation or native gardens, feel free to contact me. I will be happy to answer your questions and give any help I can give. Thank you.
Great. I see some questions in the Q&A. Okay, so the first question from RJ, if the main system pressure is higher than the drip, how can a backflow happen? Do you really need a backflow preventer?
You do. you do need, because it's water and all kinds of scenarios can happen. The backflow preventer is the only sure way to make sure no irrigation water will go back into the main line. Yeah, with the pressure regulator, yes, it can reduce a lot of that scenario, but still, yeah, I think it's from the best practice perspective, you just need a backflow preventer.
I believe that is a city policy as well, that we require
Yeah.
backflows.
Yeah, exactly.
Great. From Elizabeth, do you need to scale your pressure regulator to the number of emitters on your line?
I think, yeah, in theory you do, but unless you have many emitters, right? If it's just a typical garden, residential garden, anywhere like 25 psi should accommodate most of the scenario. Anything from 15 to 30. Yeah, unless you really have that many emitters, that many plants. So usually, and that's also why the planning is important. You want to make sure that you don't have too many emitters or too many plants to cover in one single tube, so that the pressure will reduce too much at the end. So I would say try to have a relatively even number of plants to cover for each line. That might be helpful.
Great. We have a question from Jay.
Mm-hmm.
What happens if a pressure regulator is not used? Do the emitters exceed their gallons per hour or something else?
It should not, because by design, it's the gallon per hour is set. It's the spec of the product. It should not dependent so much on the pressure. So I think the key is to make sure you reach at least, let's say, 20 to 30 psi for the drip to function relatively normally.
Great. From Elizabeth, how do you size your feed lines to count and rate of your emitters?
I don't understand this too well. What's the?
Elizabeth, are you on the call? Okay, we'll come back to this one. Maybe she, if she's on the call, she can raise her hand. Okay. Jay has a question. I have a peach and plum tree. I water them consistently from May to November. Could I water them less after they are no longer bearing fruit?
Yeah, I in theory, yeah. Well,
and Jay,
don't.
So go ahead, Chelsea.
So sorry. Yeah, I think I wanted to say you don't know unless you are sure, right? The reason it's not. I think the key is that you find out exactly why it is not having as many fruits as before. If I wanted to say if it's really because it's over its peak and it's because of its age, then yeah, it makes sense to reduce the water. But if there are other reasons and maybe it can still be revived, then maybe it can still water the same amount and at least for a while and see how it goes, and just make sure that it's really over its peak because of that.
Great. I see that Elizabeth has raised her hand, so I'm gonna allow you to talk, Elizabeth, so you can ask your question directly. I think you just have to unmute.
Hi, thank you.
Mhm.
So I guess my question is like, maybe how do you size your, so you have like you have these like various lines here in your drawing, right? You have a 1 inch line feeding like these three, what are they? 3/4 inch lines, and then you have a 1/2 inch like black line running on the surface there, right?
Mhm.
What flow rate, right, can that 1/2 inch pipe support, right? So like if you have
Mhm.
10 30 gallon emitters, is that too much, or what, how do you calculate that?
Uh, it's hard to give one answer. So I think the key is to look at the spec when you buy the drip product and find out how many gallons um, that specific product has. So let's say,
So let's say I have like 10 gallon per hour emitters, right? So that's like 100 gallons per hour. How do I know what size feed line can accommodate that? Is there
wait,
like,
you have 1 gallon per hour. So it's 10 gallons per hour, right? Not 100.
I'm just making up numbers that are round for fun, right? Like, so like what I'm getting at is there like a formula or a calculator or something out there that says a 1/2 inch pipe can support this many emitters of this flow rate or something?
Mm. I think the key actually is the pressure. As long as the pressure is there, it
Okay.
yeah, as long as the pressure is there, the emitters should not number of emitters should not um
But I would imagine each emitter reduces your
yes,
head height, right? And so,
it reduces the pressure.
yeah.
So as long as you have still have enough pressure at the end of the line, you should be fine.
Okay. Thank you.
Mhm.
I know there's some irrigation hardware stores that you, when you're purchasing the material, can ask as well.
Yeah.
We have a question about where the scheduler program is from, what website to go to.
I think it's a Valley Water. Just Google Valley Water irrigation scheduler, and you should
And
come up.
I can include that link in our follow-up email
Mhm.
as well.
Mhm.
Okay. What do you do if you already have the valves set up and different plants on each of the valves, so you can't set them up with plants and trees separately?
Well, then maybe if you can't do it yourself, maybe have someone, a contractor or someone who can knows how to do the irrigation work to just reroute it so that just yeah, have one line for different types of plants and then program that line on the different stations. Yeah, that would be the best way to go about that.
Great. And then we have a question from Kat. Are there low water use veggies? And do most veggies count as medium or high water use? I do want to give a quick shout out. We are doing a edible gardening class coming up in November where we'll be able to get into this as well. But go ahead, Shelky.
Yeah, I think most plants are relatively high water use. I remember there are some that are lower water use, but I don't have those in my mind right now. Um, yeah, so yeah, the one good way is to, again, just have different water zones, right? For example, if you have two beds, then put the higher water use in one bed and the lower water use in another bed. And then you can schedule have different schedules programmed for each bed.
And yeah, Kat, if you join our November 13th class, we're going to be diving directly into edible gardens and plants on using less water for them.
Mm-hmm.
Great. I don't see any other questions, but if you want to raise your hand and ask Shelky directly, or if you want to put something in the Q&A, we have some more time. Give it a couple minutes. Any other questions for Shelky? I don't. Oh, here from Kat. Are there good mapping tools for irrigation hoses so you don't accidentally cut them?
I right now I don't have anything on the top of my mind.
Maybe Shelky, if you come up with
Yeah.
something later, you can message me
Sure.
and I
Yeah.
can follow up. I will also include Shelky's contact information as well, so you guys can follow up with that as well. Good question.
Yeah, exactly.
Any other questions for Shelky? Don't see anything yet. All right. I guess thank you everyone for joining us. Thank you, Shelky. As I said, this webinar is recorded, so we'll send that out. We'll send out links to the relevant rebates, Shelky's contact information, etc. Thank you all so much and hope to see you at our future classes. Have a good night.
Thank you. Good night.